Welcome to the deep dive. Today, we're going to be talking about personalized AI that's also super private. I know, right? It sounds kind of like we're stepping into a sci-fi movie, but this stuff is real and it's really changing the way we think about AI. We're diving deep into a research paper. The title is a mouthful. It's called pFedMoE. Data level personalization with mixture of experts for model heterogeneous personalized federated learning. Yeah, I know. But don't worry, we'll break it all down for you. Buckle up, because we're about to unpack some serious AI innovation.
It is fascinating stuff, and it does have huge implications for the future.
All right, so first things first. Federated learning, or FL. Imagine this. You get all the benefits of a powerful AI model, but without ever having to actually share your personal data.
That's a great analogy.
It's like having a world-class chef create a dish based on your feedback, but they never have to step foot in your kitchen.
In federated learning, the training happens right on your device, using your own data. So only tiny snippets of information about the updated model are sent back to a central server. That way, the central model gets smarter without anyone ever having to reveal their raw data.
Ah, so it's like a global collaboration, but everyone keeps their secrets safe? That's amazing.
Yeah.
But I have a feeling there's a catch.
Right. Not all devices and data are created equal.
Exactly. And that's where things get even more interesting. Not everyone has the latest smartphone. And we all have different types of data. You might use your phone mostly for social media while someone else is using theirs for fitness tracking. That's what we call data heterogeneity. And then on top of that, we have different devices with different capabilities too. Phones, laptops, servers, you name it. We call that system heterogeneity. Oh, and I almost forgot, there's also model heterogeneity. This is especially relevant when companies want to collaborate but don't want to reveal their secret AI sauce. Okay, so it sounds like we're trying to organize a potluck dinner where everyone brings different dishes, uses different cooking techniques, and some people are even hesitant to share their recipes. That's got to be a challenge. So that's where model heterogeneous personalized federated learning, or MHPFL, steps in. But how do we actually solve this puzzle? How do we create a personalized AI experience in such a diverse environment?
This is where our research paper comes in. It proposes a method called pFedMoE, and it uses something called a mixture of experts, or MOE. So picture this. You've got a team of AI specialists, and each one is an expert in a particular area. Then they join forces to solve a problem, like a superpowered AI team-up.
Okay, I'm definitely intrigued. So how does this mixture of experts actually work?
Well, with pFedMoE, each user gets their own personalized model. It's like a unique blend of a shared global expert model and their own local expert model. And this blend is adjusted based on the data being processed.
Ah, so it's like having a global brain trust and your own personal AI assistant working together. To give you the best of both worlds, I'm starting to see how this could be a game changer.
Absolutely. And here's the key. There's a gating network that decides how much to rely on the global expert versus the local expert for each piece of data.
Okay.
It's like a smart traffic controller, directing the flow of information to the right expert at the right time. And the best part, this gating network is personalized too. It learns from your data. But get this, it never leaves your device. Talk about privacy.
Wow. So we've got personalized models, a team of experts, and an ultra-private gating network. What's the real-world impact of all of this? I mean, this sounds amazing in theory, but how will pFedMoE actually change things for, the average person?
Well, imagine you're using a health tracking app on your smartwatch. With pFedMoE, it could give you super personalized recommendations based on your data,
Oh,
all without that data ever leaving your device. It could even help predict potential health issues earlier and more accurately.
wow, that's incredible. What about spam emails? Could pFedMoE help with that too?
Absolutely. Imagine a spam filter that learns your specific email habits. And it gets so good at it that it blocks unwanted messages before you even see them. It's like having a personal assistant who knows exactly what you want and don't want to read.
Okay, now I'm on board with this pFedMoE thing, but let's break down how this gating network actually works for a second. You said it's a lightweight linear network. What does that even mean?
It sounds complicated, but it's actually very elegant. Think of the gating network as a mini neural network, working behind the scenes, so to speak. It's made up of linear layers, normalization layers, and activation functions.
Okay, that's a lot of technical stuff. Can you break it down for us, non-AI experts? What do these layers actually do?
Sure. Let's start with linear layers. They transform the input data into a format the network can understand, kind of like translating a foreign language into something the AI can comprehend. They basically prepare the data for decision-making.
Ah, so they set the stage.
Exactly. Then we have normalization layers. These keep the data flowing smoothly through the network. They prevent extreme values from messing things up. Think of it like a sound engineer, making sure all the instruments in an orchestra are balanced.
That's a great analogy. Okay, so what about activation functions? What do those do?
Well, activation functions add a bit of spice to the mix. They introduce nonlinearity, and that's super important for making complex decisions. It's like adding flavor to a dish to make it more interesting.
So these activation functions are what allow the gating network to make those decisions. Like, hey, this data point needs more the local expert, or nope, this one needs a heavy dose of the global expert.
You got it. It's like a dynamic dance between the global and local experts, all orchestrated by this clever gating network. And the researchers have chosen each component carefully to make it as efficient and effective as possible.
Okay, so let's take a step back for a second. Why should anyone care about all this technical stuff? What makes pFedMoE really special? Yeah, that's what I want to know. It's easy to get lost in the technical stuff, but I want to know how this impacts the everyday user. Give me the so what.
Okay, so here's the so what.
Hmm.
pFedMoE is like the ultimate personalized AI experience. It means your health app can give you advice that's specifically tailored to your body and your lifestyle. Your spam filter can block unwanted emails with, like, laser precision, and your voice assistant can understand you like a close friend. And it does all of this while keeping your data safe and sound on your device.
Okay, that's pretty impressive. But how do we know it actually works? Did the researchers actually see good results when they tested pFedMo?
Oh yeah, for sure. They put pFedMo to the test using image datasets called CFAR10 and CFAR100. These are like standard benchmarks used in AI research. And guess what? pFedMo consistently outperformed existing methods when it came to accuracy.
So it's not just hype, it actually delivers.
Yeah.
But how much more accurate are we talking?
We're talking a significant improvement. In some cases, pFedMo was up to 22% more accurate. That's huge.
Whoa, that is a game changer. But I'm also thinking about the practical side of things, all this personalization. It must require a lot of computing power, right? Wouldn't it drain our batteries and slow down our devices?
That's a really good question, and it's definitely a common concern with these types of AI models. But here's the thing about pFedMo. It's super efficient. Remember, only tiny bits of information are exchanged between your device and the central server, not the entire data sets. So it's actually lightweight and doesn't hog your device's resources.
So it's a win-win. Powerful personalization without sacrificing performance. Okay, I'm loving this. But let's dive back into the research paper for a minute. I understand there were some visuals in there that really bring this to life. Can you walk us through them?
Yeah, absolutely. One of the most interesting things they showed was how data points clustered differently depending on the model used. They compared pFedMo to another method called FedProto. And with pFedMo, the data points formed these, really well-defined clusters. It was like pFedMo could see subtle differences that other methods just missed completely.
So it's like having a high-powered magnifying glass for your data, basically. It helps you see those finer details. But can you give me a concrete example of what these clusters might look like?
Sure. Imagine you're looking at a scatter plot of data points. Each point represents something you've interacted with, like a song you've listened to or an article you've read. With a traditional model, these data points might be all jumbled together. But with pFedMo, they start to separate out into distinct groups based on their underlying similarities. It's kind of like those magic eye pictures, where you have to relax your eyes just right to see the 3D image.
Ah, okay, I can picture that. So with pFedMo, it's like the data points suddenly jump out at you and form these meaningful patterns. It's like a visual representation of personalization in action.
Exactly. But there's another fascinating detail that came out of this paper. Different types of data can have wildly different weights assigned to the local versus global expert.
Wait, hold on. I'm not sure I follow. Can you break that down a bit more?
Sure. Remember how we talked about the gating network acting like a smart switch, deciding how much to rely on each expert? Well, the researchers found that for some types of data, the gating network relied heavily on the local expert. But for other types, it leaned more on the global expert. And this ratio could be dramatically different, really different.
So it's like the model is saying, hey, this data is really specific to this person. We need the local expert to step in. But for other data, it's more like, this is more general knowledge. Let's go with the global expert.
Exactly. And that's what makes this approach so powerful. It allows the model to adapt at a really fine-grained level. It's true personalization, tailored to each individual data point.
Wow, my mind is blown. This is way beyond just basic personalization. It's like pFedMo is conducting a personalized symphony for every single piece of data you have.
I love that analogy. It really captures the essence of pFedMo. But the story doesn't end there. The researchers are already looking at ways to take pFedMo to the next level.
Okay, tell me more. What's next for pFedMo?
Well, one of the things they're exploring is how to use pFedMoE for something called federated continuous learning. This is where the data is constantly changing, you know, like stock prices or news feeds.
Ah, so the AI model has to keep up with real-time data, constantly adapting and learning. That's gotta be tough.
It is. And that's where traditional AI models often struggle. But pFedMoE, with its ability to adapt at the data level, well, it could be a game changer in this domain. Imagine personalized financial advice that updates in real time based on market fluctuations, or a news feed that's so finely tuned to your interests that it feels like it's reading your mind.
We're talking some serious next-level AI stuff here. It feels like we're stepping to the future.
It does, doesn't it? And that's what's so exciting about this research. It's not just a theoretical concept. It's a practical and promising approach to building a future where AI is more intelligent, personalized, and seamlessly integrated into our lives.
Before we get too lost in the future, let's come back to the present for a sec. You mentioned earlier that the research paper included some mathematical proof. Can you give us a glimpse into that? I have to admit, math is not my strongest suit.
I understand. Don't worry, I'll keep it simple. One of the things researchers have to prove is that their algorithm actually converges. In other words, they have to show that the model will eventually settle on a stable solution. It won't just bounce around forever.
So it's like making sure your spaceship will actually reach its destination instead of getting lost in space.
Exactly. And the researchers behind pFedMoE were able to mathematically demonstrate that their algorithm does converge. They even calculated its convergence rate, which tells you how quickly it learns and arrives at a stable solution. They use some technical terms like non-convex convergence rate and O1T, but the point is, pFedMoE is backed by some solid math.
Okay, good to know. It means these impressive results aren't just a fluke. They're grounded in real theoretical foundations. This is starting to feel like pFedMoE is the real deal.
It definitely is. That's why this research is creating so much buzz in the AI community. It's not just a theoretical exercise. It's a practical and promising approach to building a future where AI is both powerful and respectful of our privacy.
Wow, we've covered a lot today. From the basics of federated learning to the inner workings of pFedMoE. And we even talked about its potential to, like, totally change the AI world. I feel like I just went through AI boot camp.
It has been quite a journey,
Right.
but it really shows you how quickly AI is evolving.
For sure. And speaking of evolution, I can't help but wonder about the future of pFedMoE. What other applications do you see for this tech? We talked about healthcare, spam filtering, voice assistance, but where else could this lead us?
Honestly, the possibilities are pretty much endless. The really cool thing about pFedMoE is how versatile it is. Imagine a world where every student has access to personalized education software, software that adapts to their learning style and how fast they learn. It could completely change education and help students reach their full potential.
Yeah, that's amazing. Personalized education could be huge, especially for students who, struggle with traditional learning.
Exactly. And let's not forget about healthcare. pFedMoE could help make medical diagnoses more accurate and faster by training AI models on huge data sets of patient data. It could even lead to personalized medicine, tailored to your genes and your lifestyle.
Wow, those are some really big applications. It sounds like pFedMoE could help us solve some of the biggest problems facing humanity.
It definitely has that potential. And beyond those super important areas, we can't forget about how pFedMoE could boost our creative lives. Imagine getting music recommendations that are so personalized. They introduce you to artists and genres you'd never even thought of, expanding your musical horizons in, mind-blowing ways.
As a music lover, that's definitely something I'm into. I'm always looking for new music to listen to, and an AI that could make a playlist based on my specific taste would be awesome.
I hear you. And let's not forget about writers. Imagine having AI-powered writing tools that help you write stories and articles that are truly unique, amplifying your voice and helping you get past writer's block.
Okay, that's both exciting and a bit scary, to be honest. As someone who writes a lot, I'm intrigued by that idea. But it also raises questions about the role of AI in creativity, right?
That's a great point. AI is a super powerful tool, and we need to make sure we use it responsibly and ethically. But I think pFedMoE, with its focus on privacy and personalization, gives us a way forward, a path to an AI future that's both beneficial and aligns with human values.
I agree. It's all about finding that balance, harnessing the power of AI while making sure it helps humanity and empowers people.
Exactly. That's what makes this research so exciting. It's not just about building smarter machines. It's about creating a future where AI makes our lives better and helps us solve the world's biggest problems.
Well said. Well, I think it's time for us to come up for air after this deep dive. We explored pFedMoE pretty thoroughly, from its technical details to its potential to revolutionize industries and our lives. It's been quite the journey.
It's been a pleasure exploring all this with you. I hope our listeners enjoyed it too.
Me too. And thanks to everyone for joining us on this adventure. Remember, even the most complicated research can be super interesting and even inspiring once you break it down. So keep exploring, keep learning, and keep asking questions.
We'll see you on our next deep dive.